Welcome to Stall Side Podcast.
Pat, how you doing?
I'm great. How are you today, Peter?
Good, thanks. Pretty excited about today's show. We have Dr. Martin Nielsen from the Dluck Research Centre talking about equine parasites.
Yeah, I'm looking forward to it. He's one of the very few people in the world who is doing research on the topic, and things are changing. It seems a very basic concept, but it's fairly dynamic.
Yeah, I think parasites was something that everybody thought was done and dusted, and there were some very effective deworming products on the market. But, you know, nature being what it is, parasites have very adequately staged a recovery and now are a big problem.
Yeah, they've learned how to evade the products that we've got on the market, and it's not just a formula anymore where you give one then give the other, and it's changed.
Yep, there's no recipes anymore. And having been accused of being a parasite myself at some times, I'm just really looking forward to seeing what I can learn here today.
Yeah, you've evaded everything, haven't you?
I have evaded everything, including immigration. So, welcome to Stallside. Coming up next, Dr. Martin Nielsen from the Dluck Equine Research Centre. Martin, welcome to Stallside.
Well, thank you for having me. It's a pleasure.
Appreciate you being here with us today.
Yeah, thanks for your time. Tell us a little bit about yourself.
Well, I ain't from around here, as they say. I'm from Denmark and born and raised, and went to vet school there as well. During my time in vet school, I sort of started realizing that I liked research. I was not really aware of that being a thing for me when I started vet school, but I just realized that, you know, when you were doing projects, I kind of liked that work a lot. And a lot of my buddies in vet school didn't. They were like, oh, I hate to have to write this, you know, dissertation or whatever it was. But I really liked it. And then at the time, we had a very busy research program in parasitology, one of the most best funded programs at the school. So lots of opportunities for students to get a little bit of a job where you could learn something and make money at the same time. So I was one of many, many students who got involved with some of the research that was done in parasitology. And being a horse guy, I grew up on a horse farm. My mom ran a riding school and a training facility for a long time. So horses have always been in my blood. So I was just like maybe looking for that idea of something with parasites and horses. And no one was doing that at the time. I mean, they had all these research programs and all kinds of other animals and other parasite systems, but nothing was going on in horses. And so I was sort of really contemplating that idea. And then when I was getting ready to graduate with my DVM, my wife said, yeah, Martin, that all sounds great, but you don't want to be a nerd. And so, you know, do what you set out to do, or at least try that out first, to go to practice. And because that was your idea to begin with. And I was like, yeah, she's right. I should actually try and leave this facility and potentially come back. I mean, so the situation in a small country like Denmark, I think, is probably similar to New Zealand, where you have one veterinary school. Mm-hmm. And so there's only one place you can go and pursue a degree in veterinary, a PhD in veterinary medicine, or veterinary science, right? That would be going back to that same facility. So if you end up, never ever leaving that place, it's like every university is like a little village in itself, and sort of a paranormal society in many ways. You kind of lose some perspective a little bit. And so she was right. So I went out and I worked actually for 3 years in practice, primarily equine, and a little bit of a few other ruminants and hobby ruminants and things like that, a few dairy farms, but mostly horses. And in many ways, I enjoyed that life. I particularly enjoyed the fact that you go to work and you never really know what awaits. There are not 2 days that are alike, and you drive around your truck and you interact with people all day long and communicate with them, and all of that I really, really loved. What I didn't like was this feeling of having to pretend I knew much more than I actually did. I had to sort of pretend I had knowledge about everything, and I might have had a little bit of knowledge, but it was very superficial. So for me, it was this conundrum of being a generalist and not really knowing very much underneath that superficial layer, which wasn't very satisfying to me.
I a lot of I'll chime in there because you get a lot of people all the time. People say, "Well, and my line is not near as much as you think I do."
Yeah, and I really wanted to sort of be in that situation where I could say, "Well, I actually don't know anything about this, and I'm not even going to pretend I know anything about this." But what I can say is, I should know at least something about this topic, or if I don't know, I'll do whatever I can to educate myself and others about it, in other words, to become the specialist. And so I could have chosen to stay in practice like many people do and sought specialization in that regard. And I think that might have also worked out for me, but I did have that research idea in mind, and that brought me back to the University of Copenhagen, and I started a PhD. So I wanted to do equine parasitology, and there was no one there doing that. And so you kind of need a supervisor. And so I had two great supervisors that were very supportive. They knew about, one was a clinician, the other one was a parasitology. So it was sort of a good combination. But whenever you need, you're tasked with defining what your research is going to be, you need to know all of the things that never got published, right? The things that were tried out, the thoughts that people might have had, the discussions that might have occurred in the past about various ideas. And if you are not active in that field, there's no way you know that, right? So that's what brought me to the States. I mean, it's a long-winded story, I'm sorry. But it brought me here as a PhD student. I just started emailing people that I'd seen in the literature that were publishing on equine parasites, and I wanted to do something with diagnostics, so I was looking specifically for that. And there were, at that time, this was almost 20 years ago, about 4 or 5 people, big name people here in the States that were all actively working on equine parasitology and doing research with it. And one of them responded and said, "Hey, you should come here, Martin. And while you're here, you should take, quote, a small circular drive around the southeastern United States." And, I'd never been to the U.S. before. I thought, okay, that sounds like a few hours of driving. That's not a problem. I came to realize that was like a matter of driving from Baton Rouge to Kentucky. That was a day and a half, and very, very different distances than I was used to coming from little Denmark. But that was a career-defining trip for me. I ended up meeting with 4 different people, big-name people that all became an important part of my network. And to this day, one of them was here in Kentucky, Dr. Gene Lyons. And we started collaborating. Another one was Ray Kaplan at University of Georgia, and I actually ended up doing part of my PhD with him, working on PCRs for one of the parasites I work with. And he's still a great mentor for me today, and a dear friend. And I think the connection with Gene Lyons also, long story short, I won't bore you with that, but it's also part of how I ended up at Gluck years later. But I started working at Copenhagen as a faculty member and had the opportunity to come here on a sabbatical leave. And that's when the people at the Gluck at the time started talking to me about, "Hey, Martin, what are your career plans? Could you imagine working in the U.S.?" And I said, "You need to talk to my wife." And so they did. And she said, sure, she would be open for the idea. And long story short, I've been here 10 years now. It's just been my 10-year anniversary. And I feel like I've come to the perfectly right place for me. I mean, I listen to you guys' podcast, and you often bring up the fact that this is a unique place. This area is unique because of all of the expertise and the critical mass of people that are working with all aspects of the horse and health, and we do the research, and there's the diagnostic work. You had Rebecca Ruby recently, and I agree. I mean, there's this unique focus on the horse and health and the research and all of these great minds and all of this knowledge. You don't find that anywhere else in the world. And I just feel like I'm extremely fortunate to have been given this chance and opportunity to come here, and I enjoy every day, honestly.
Equine parasites.
Oh, yeah.
What do people need to know?
Oh, a lot. I mean, there's a lot of misconceptions or myths out there, and I've tried to sort of address a lot of those in various ways. I've sort of been experimenting with it a little bit. I mean, I had I have a YouTube channel, so I had a video series that I named Deworm Debunk. So trying to debunk some of those myths. I think if I were to distill it, and I believe that's probably what you guys want me to do, the number one thing right now is ask people, do you know if what you deworm with actually works? And if they say yes, I would always ask, okay, how do you know? Because have you ever tested the efficacy? And the reason why I focus on that is that most people don't. They might do some egg counts on their horses, so we call it pre-treatment egg counts. But if you don't do the post-treatment counts, you are really missing the major point here. And that's really the number one thing that everyone should be doing. Test what you're doing, and then maybe make some changes, because I guarantee you most people are likely to actually find some degree of resistance in at least one of the parasites that they're treating.
So when should we do those? And how many horses do you need to do? What percentage of your herd?
So the minimum that we have defined right now in the guidelines. So I am the lead author of the AAEP equine parasite control guidelines. They're due for an update this coming year, so we'll be updating that a little bit. But what we have right now is 6 horses. And so 6 horses that are Strongjaw, 8 count positive pre-treatment. And if you have that, you have a meaningful sample of that population. Now, that those 6 horses should represent a population use. So that'll be, if you have a herd that's on the same field, in the same group. So you don't necessarily have to test them all, which is good, right? It's not like when you're doing some of the other things we often recommend, certainly in adult horses, where you're screening the level of egg count or level of shedding and to find the high shedders and all that stuff. That's where you need to test everything, which can be a huge effort if you have large farms. But it's not really a matter of a percentage of the herd, but you need to account for some of the variability that you can see between individual horses, at least 6. And the way to think about a horse when it comes to resistance testing is that you're not really testing the horses. I think we all know this, but a lot of clients don't understand that. They think that it's their horse that they're testing. No, we're testing the parasite population, right? And all the horses share the population. And so what each individual horse that go into the test is a biological sample of that population. And so if you have 6 horses, you have 6 biological samples. There's going to be some variability. But if you then make an inference across those 6 horses, that's a better test than if you only do 2 or 3 or 1. Now, there may be examples where you don't have more horses than 3. And people often ask me, so then I can't do the test, can I? I say, yes, you can do the test, but you just need to be more cautious with interpreting the results. Yeah. It is not as... it's a more variable result, but it can still be useful as long as you exercise the caution in interpreting the test. So I really, in the past couple years, I've really changed my message to, I used to sort of talk about, well, you need to do egg counts. And then, after having talked about that for several minutes, I would maybe mention sort of down the line that, and resistance testing is good too, right? I now turn that upside down. So I talk about resistance testing first and foremost. I think that's the most important reason for doing egg counts. To provoke it a little bit, I often, when I talk to clients, horse owners, I tell them, you don't need to do a test to find out if your horse has parasites, because it does. Right. It has parasites.
And I think that's hard for people to understand too, is, they don't think that, but they coexist.
Yeah. Yeah. Yeah, no, and that's another message that I try to repeat as much as I can is it's just as normal for horses to have parasites as it is for them to have bacteria in their gut. And that seems a little mind-blowing to some people. But yeah, they have bunches of bacteria, but you just can't see them, so they don't bother you as much. But you can see the worms that are coming out sometimes. And that bothers people because they're gross. And I agree, they can look very gross. But they, as a general rule, they don't cause disease left and right. I mean, we have disease in the exceptional cases, so it's the exception rather than the rule. And the whole name of the game, of course, is to minimize the risk of that happening. We don't see in this area, for example, here in Central Kentucky, we don't see a whole lot of parasitic disease. You guys can disagree with me if that's the case. But I mean, we see cases, but we don't see a lot. in my opinion. I mean, I don't hear about a lot, at least. I would hear about them if there were like huge problems going on. But we probably see a few cases every year. We see some ascarid impactions in the falls. The one thing I ask about whenever I talk to practitioners, again, that's one of the many, many great things of working in this area. There's so many people out there that are, out there seeing cases and involved with what's going on the farms every day. And the feedback for someone like me who's doing research is absolutely critical. That's really, I need to be up to date with what's going on. And so I always enjoy these conversations. And one of the things I ask about is, raise of hands, how many have seen a case of larval cyathistominosis in the past 5 years? And so larval cyathistominosis is the disease that's caused by the small strongyle parasites, and it's the larval stages. You guys all know this. And that the larval stages that are insisting in the wall of the intestinal wall of the large intestines, and if there's several hundred thousands of those and they all decide to emerge at the same time, that's where you can have the diarrhea that this disease syndrome is characterized by. And that's when I started in vet school many years ago now, almost 30 years ago. That's what we were learning about. And it was a big hot topic at the time, especially in Northern Europe. And there was quite a bit of research going on with this disease syndrome, how to handle it, and the prognosis was really poor. A lot of 50% of the horses died, and how to best treat and manage these, and they would just lose so much protein and fluid, and it was like an uphill battle to just keep enough fluid in these horses, and that was a big talk of the town in the 90s and up until about year 2000, and then all of a sudden, it's like there's not all that many going on and or happening, and certainly not around here, which is just interesting. So whenever I ask the question, I usually don't get any hands in the room in this area. I think if you go a bit further north, you might see more cases. But that's also interesting. What happened? Why? Or did it ever happen? Did it change? Or have vets in the field become better at handling these cases? Or is there something in the management that has changed the dynamic? Why don't we see that particular syndrome anymore? Bottom line is that we don't really see it very much. And so things change sometimes, and we struggle to understand why.
Mm-hmm. You mentioned about resistance to the parasiticide that you're using. We've got really a small number of compounds that we can use.
Yeah.
Could you sort of go through your approach to using those compounds?
Yeah. So there's only 3 classes, and that's what we've had for a long time. And I think it's kind of puzzling to think about that the newest member of this class is about 40 years old. Ivermectin was introduced in the early 1980s, and we had moxidectin sort of introduced in the 90s, but that's still a member of the same class. So we haven't had anything new introduced to the equine market for 40 years. And that's why we have the situation we have, right? And then the 2 other members, the 2 other classes are even older. So we have the pyrimidines, they were the parental products, they were introduced in the 70s. And then the oldest class is the benzimidazoles, introduced in the 60s. And so we're looking at 40-year-old products, 50-year-old products, and then some 60-year-old products, and that's all we have. And we've seen actually resistance documented to all 3 classes in certainly 2 major parasite groups. So the small strongyle cyathistomins, the ones I just talked about, is one. And that's actually where we're beginning to see, very alarmingly, multi-drug resistance, and in some cases in this area, actually, complete drug failure, treatment failure of all 3 antibiotics on the same farm. So essentially, just none of the drugs would reduce treatments up to the snuff, to the level that they were marketed at and launched at. And so it's disturbing because we don't have anything to replace them with. So once we run out, we don't really have anything. With the ascarids, we're beginning to see something similar. We have a lot of resistance to macrocyclic lactones, to ivermectin, moxidectin. And that's also global. It's across the world. It's one of those things, if you decide to test it, you're most likely to find ascarids to be resistant to this class. And then emerging reports of resistance to the 2 other classes as well. So the drug industry, the pharmaceutical industry, hasn't developed anything new for horses since ivermectin. And the big question is always, so why? why haven't they done that? And I think there's probably a bunch of reasons, and many of them I may not understand or know, but one of them is that equine is still a small market. And of course, you could hope for something developed for ruminants, for sheep in New Zealand, for example, or Australia, and then that active also being useful in horses. However, that hasn't happened, which is also astounding. I mean, there's been 2 new anthelmintic classes developed and launched for use in sheep in the past 20 years. Neither of those made it to the market here, even for ruminants. And neither of you, I haven't seen any data on their usefulness in horses. One I heard was actually toxic to horses, so they got some ileus problems and when administered this product, so that's not going to ever be a thing. But then the other one, we just don't know. The other one is Monteponto, and also what they found in New Zealand was when they launched it, it didn't take many years before the first reports of drug resistance showed up. It showed up in the goats. In goats always first, because goats are not sheep. But if you dose them like you do sheep, then maybe you actually effectively underdose. And so they saw resistance in parasites of goats that are same species or closely related to the species infecting sheep. And a few years later, they also saw it in sheep. So that might also be a reason why that product hasn't been introduced more widely than Southern Hemisphere, which is really where we've seen it. And so there's been some new classes. There's also one for dogs and cats, imodepside. Again, interesting that those 3 examples were only introduced and launched for a couple animal species at the time, if not just one, which is very, very different from the approach that the pharmaceutical industry took, with all the other examples we just talked about, where they went for the broadest label claims possible in the many applications as possible, as many different parasite species as possible, but also as many different animal species as possible. And there could be a number of different reasons why that is. I probably, like I said, don't know them all, but it's demonstrated that it is not that easy to find these good candidates, these good drug candidates. And maybe as a scientific field, we were just incredibly lucky with ivermectin. I think if you look into the history of that, how that was discovered, I think it was something about somebody taking a stroll on a golf course and deciding to pick a soil sample and bring it home to the lab. And he was looking for something else, but there was a fungus in there that was secreting something that kept killing the parasites. So it's kind of similar to how penicillin was discovered, which also was by accident. So some of the best discoveries in science were more or less by accident, but it took some people to see the potential, right, and bring it to where it was. And there were a couple of guys who got the Nobel Prize for that a few years ago. So, but that is maybe that exceptional example that we'll never ever see again. Ivermectin has been such a success in terms of spectrum, safety, and all of that. Probably we're not going to see anything like that again. We probably will be looking at a scenario where these new products, if we ever get to see them, will be much more narrow spectrum. And some of the old ones may actually come back. We might, forced by circumstances, have to do that. Some of the ones that are not on the market anymore.
So how do we manage our way through this resistance? You've just emphasized we only have a very small number of compounds. They've been around a long time. Resistance is rampant to all of them.
Yeah.
What are we going to do? How do we manage our way around this problem with the tools that we have?
Yeah, I mean, I think the only thing we can really do is to delay resistance development. We can't prevent it, but we can affect the rate at which it's happened. And one of the things I've done with my collaborators in New Zealand is to look at this from a computer simulation standpoint, a modeling standpoint, where you can, because the thing about resistance is that it doesn't happen overnight. It's something that takes years. In the parasite, it takes years to develop. And once it's developed, it never goes away again. And that's another thing that separates the parasites from the bacteria. And so in order to really look at which scenarios might be the better and more sustainable treatment approaches, you need that long-term perspective that you can't really get in many studies. And so that's where the simulations come in handy. And we've done quite a bit of work on that. There's a lot of concepts that definitely seem to work. There's been a push for the whole idea of combination deworming. Now, that's not a one solution fits all solution. In many cases, it may actually not help. But what we've shown is that in scenarios where you have a new active with a new mode of action that to which no resistance has developed, okay, that's pretty much not a realistic scenario right now. But that actually was what they had with some of those cheap products I talked about before. And if you have two of those, maybe in a future scenario, and you combine those, that's more sustainable. Resistance will be slower to develop if you combine the two products rather than rotating between them, like has been done traditionally. So I think that's interesting. Now, the questions we then asked was, well, okay, that's not the scenario we have with horses. We don't have two actives to which no resistance has developed. We only have three actives to which resistance has developed. And so is there any value to combining any of those? And we did several simulation studies. We also did a couple studies with a research herd we have here at the UK North Farm, and we have a herd of Shetland ponies that have double drug resistant cyathostomy parasites. So those are resistant to two classes, to the pyrimidines and the benzimidazoles. So that's actually what I call a mini simulation of a real life scenario, because that is what most farms would have too, like resistance to two of the three. And so we were able to say, okay, if we combine these two actives, so pyrantel and one of the benzimidazoles, we use anthelcide, oxybenzole. Is that any better than just treating with them on their own? So single active efficacy was about 60% for both or thereabouts. So that's a clear definition of resistance. And, a point there is that even when you have resistance, you might still actually see a reduction. It's just not up where it should be anymore. So the question was, okay, so if you combine these two 60% actives into a combination deworming, what are the benefits? Are you going to get anything better? And so the answer was yes. We got about 75% reduction, 80% in that range. So that is, numerically better than 60. So maybe that was a better approach. But then again, it wasn't up there in the 90s that we would have liked it to be. And so we repeated that treatment 4 times within 1 year, so 2 months apart, which is what a lot of people still do, although we don't recommend deworming that frequently. And so the first time we got the 75, 80% reduction. Second time we did it, the efficacy was already down to 40%. Third time, it was 40% again. And the third time, it was still 40%. So what looked like it was maybe somewhat useful at first, very quickly turned out to not be. So that wasn't the solution. And so I think to just complicate the matters here, so combination deworming may work, it may be good, but you need to know what the starting efficacy is. And if that's not high enough, you're probably going to see what we saw. We then did another combination study. So this miniature herd has never been exposed to any of the macrocyclic lactones, so the parasites were completely naive to those drugs, and so that was sort of the scenario of introducing the new active to which no resistant had developed, and so we were then wondering whether there would be any value of taking moxidectin as an example of the new drug, with no resistance developed, and combining that to any of these other ones that wouldn't be useful anyway. And so when you think of that, that's like, well, does that make any sense? Well, you're going to get 100% efficacy of moxidectin, and so you add another drug, you're still going to get 100% efficacy. So what's the point? Now, that's where the simulation came in. So we were looking at, okay, is the resistance to this moxidectin, is that going to be slower when you have that other active, even though it's not working that well? Or is it just not going to matter? And so we were able to simulate all level of efficacy of that other drug, we modeled oxybenzole. And so we said, well, 50%, 60%, 30%, all of these different levels, and looked at a 40-year period. And in all of these scenarios, the resistance development to moxidectin slowed down. So that might be a way of making use of something that would otherwise be pretty useless, and say, well, if you combine it, you're actually going to protect that new active should we ever get one. So those are some of the scenarios we're looking at. We do have a bacterial dewormer that we've been working with for several years. We have a USDA grant, second USDA grant now, looking at that, and it's a free-living soil-dwelling bacterium, Bacillus thuringiensis, that's producing some proteins that can kill all kinds of critters. So they're in a competition with all these other critters that live in the environment. And if they can kill some of them, that's the bacteria's advantage, right? And so we found that some of these proteins actually are quite potent against worms. They kill caterpillars and all these other things also, right? But some of them actually are good dewormer candidates. We've done a lot of work in vitro and shown that, okay, it works against strongylls and it works against hemongus in sheep and all looks mighty great. Now, when we give it to horses, nasogastric tube delivery, it doesn't do anything to the strongylls. It doesn't seem to have any effect against the strongylls, but it kills the ascarids and it wipes them out completely. So at least there's some promise there, but it's also a little puzzling why the strongylls don't really respond. We think, I shouldn't take all the credit here, but our hypothesis is that, it's a protein. It gets degraded. And it might be a matter of how we formulate it, encapsulate it, or whatever. The ascarids are in the small intestine, so it gets there first, right? There might be enough protein left to still have its activity and kill the worms. But the strongyls are in the large intestine, and that's I don't know how many yards down the tract, and that might all be degraded when it gets to that point. So we have a project now. We're just starting it, where we're going to look at various formulations to get enough of the protein to get to the large intestine and maybe work against the strongylls. So maybe we could have something. It looks like we actually already have something to treat the ascarids with, and that could be potentially interesting. So we're doing a lot of research. You asked about recommendations for how to avoid resistance. A lot of my recommendations are along the lines of you deworm too much, don't deworm that much, don't blindly rotate, and don't think you have to use everything on the shelf. It's no longer a valid strategy. A lot of time it's just a matter of dialing back, and you're going to get the same net result, because a lot of those treatments are probably pretty worthless. And so just to get people to realize that, I think, is a starting point many times for me, which is also why I started mentioning the value of testing for resistance. And sometimes that can be the eye-opener, and you can convince people like, hey, you're using fill-in-the-blank product here. Probably actually not doing anything. So just dialing back the treatment intensity, I think, is something I've spent a lot of time on, and that definitely also in our simulation work has been shown to also slow the rate of development of resistance. And then, of course, in the adult horses, the yearlings and the foals is sort of a separate game. But in the adults and the mature horses, we don't have to deworm all the horses all the time. We can sort of pinpoint the ones where there would be a benefit for deworming them, and then leave the rest untreated. And then you have the parasite refugia idea, where you have this big pool of parasites that are not exposed to the drug at the given time of treatment. And so you have that diluting out whatever resistant stages that might have been selected for by that treatment. So those are some of the concepts that we're trying to communicate.
Because you mentioned how hard it can be to do fecals on every horse in the herd, but it's not much more intensive than deworming every horse in the herd, and it's a lot cheaper.
Yeah, I think it depends a little bit on the dewormer, how expensive it is, or how cheap that dewormer is. If you get a generic ivermectin, I don't know what those actually go by now with all of the.
No, they're pretty cheap. You're right.
There's been the focus on ivermectin for other purposes that we may not have to talk about today, which we don't endorse. But so it depends a little bit on the drug. I do agree. One of my statements, I try to make a one-liner statement, is even the cheapest dewormer is pretty expensive if you keep using it and it doesn't work.
Yeah.
Right? So that's sort of the perspective you have to bring. We also have made quite a bit of effort in on trying to make the egg counts more affordable and actually easier to do. And so we have this automated system that we've developed and validated in my lab, where it's actually image analysis. So we have a system that takes a picture of the sample, it gets filtered, and it takes a picture, and then there's an algorithm that counts the egg on the picture. And then if you have a client who's really interested, they can get the picture, but otherwise you can save it on the file for that horse along with the x-rays or whatever other like blood sample results or whatever you have. You can save that image and you'll always pull it up later. And it can finish that count in 3 minutes. And we've demonstrated that the results are significantly more precise than any manual method, just because you've removed that person. There's no longer a microscope. There's no longer that person with a hand tally clicker who's like maneuvering through the slide, and maybe this might be the 15th slide they're doing today, and they're getting a little tired. And
yeah, it's a crappy job.
It is a crappy job in many ways. And so we've tried to make that a little bit slicker. And there's actually been a few other examples lately. I was just reviewing that for a paper I was writing. Other groups that have also developed very similar systems that are also image analysis based. So I think, in the future, and not very distant future, we're probably going to see more of these types of technique, and I think it's about time. I mean, when you think of fecal egg counts, it's pretty much, poking in a pile of poop with a stick. I mean, it's not high technology at all, right? And we kind of needed to step into a more modern era with that, just like we have with many of the other tests that we're offering. So
that's good.
What about management of the pasture? You talked about the refugia, the population of the parasite on the pasture. What can people do managing their horses to try to minimize exposure? And what population dynamics are at work in the herd to make some horses have a higher burden than others?
Yeah, I mean, those are great questions. I think it is a little difficult to completely answer these questions because a lot of it depends on weather and season and climate, because the effect of rotating between pastures or mowing pastures or mixed grazing with other species, a lot of that depends on, okay, how long can these stages survive on the pasture? How long does it take for them to die out if you want to rest the pasture before you kind of, rotate back to it? And then how quickly do they actually reach the infective stage? And those two things are interrelated in many ways. And so I used to always say, and I would say this, and when I was in New Zealand, I said this as well. I mean, in Denmark and New Zealand, we have the same kind of weather, especially North Island, New Zealand. I mean, where it doesn't get very hot, it also doesn't get very cold, but it's moist most of the time. It's perfect climate for the parasites. They love it, and they can survive for a year, if not longer. And so there's really no way you can rest that pasture long enough for the pasture infectivity of these infected larvae to reduce significantly within the same season, at least. But again, here in Kentucky, there's probably times a year where that would be effective. I'm thinking July, August, where you get these very, very hot periods where it's hard to be a Scandinavian, to be honest. Where you get the temperatures that are, running in the 90s and sometimes even 100 Fahrenheit, and actually the humidity does help. And so the reason why it works that way, the hotter, the more detrimental it is to the parasites, is because the infective stage of the strongylid parasites, so that's all the staph, the stoma, small strongylus, and large strongylus, should there be any, and they do not eat anything. So they cannot ingest any food. So they have energy stored within their cells in the form of lipids and carbohydrates. And it's like they're bringing their little lunchbox. And if they're very active, they use that up much more quickly. It's just like a reptile, right? So if it's hot, they move around a lot, especially if it's moist, because they want sort of water to swim in. And so if it's moist and hot, they wriggle around and they're very, very active, and they burn out those energy stores very, very quickly, and then they die. If it's cold, they just sit still and wait until better times. Just like the reptiles, they would wait for that sunbeam so they can get out on the rock and get heated up and become active again. And so it's counterintuitive to many people that, many people think it's the frost and the cold weather that does it, that kills these worms. It is not. Actually, on the contrary, that's what they prefer. And so I do spend a lot of time when talking to horse owners, explaining this and explaining them, no, there's no point to this deworming at the first frost. What are you gonna accomplish? I mean, you kind of need to deworm whenever there's transmission going on, and that's not when it's frost. And so trying to really change that mindset is, in my line of work, you end up having to repeat some of the same messages quite a lot. So when you have a period of like July, August here in Kentucky where it's going to get hot, there's probably value, and I talked to farm managers about this. You can maybe even, you have the mowing crew anyway, have them mow and rest the pasture for a month. And I would argue, based on and I've summarized this in a paper actually a few years ago, that the reduction of those larvae on pasture would be very significant if you do it. Now, this podcast is recorded in October, so doing it right now is probably not as good an idea, especially when we get into November, where the weather becomes more Danish, if you will. It's the kind of weather we have year-round in Denmark, right? So not looking forward to that, but where it is, you get more of the raining sideways and the gray sky and the moist grass, right? And the temperature is much lower. So and the best the parasites would like to see is constant cold with snow cover and frost, because that keeps everything stable. So the lesser the temperature fluctuations, the more stable the pasture parasite population is, and there are more stages you'll see surviving until the next spring. So now, luckily in Kentucky, we don't get that kind of weather either. We get a lot of fluctuations over winter, right? We get like night's frost and then 70 Fahrenheit during the day, right? That's not unusual, and we can get that repeatedly. We might get a cold spell, but it's not long lasting. We don't get much snow cover. We get a little bit, some years nothing, right? So the lack of stability of the cold winter weather is actually a good thing in terms of pasture infectivity the next spring. So we should be pleased about that. They don't like the undulations between frost and thaw. Several cycles of that does kill a lot of the eggs and larvae.
So how about harrowing the pastures? Does that do anything for us?
Yeah, again, so a little bit of the same idea. So what you do, what you get from harrowing, chain harrowing, or whatever system you might use, is that you break up those fecal piles. And so the fecal piles are actually, they're if they're intact, they protected a lot of the eggs and larvae, and they protect them against desiccation, but also against those temperature fluctuations. So the more that temperature, the ambient temperature, can be kept stable, the better it is for the parasites. So if you have that humidity chamber that has maybe a little bit of a firm shell on the outside and it retains a little bit of moisture on the inside, it even can withstand pretty dry periods too. So if you break that up, you're going to remove that. And so in many ways, that's good. However, you're also spreading the parasites all over the pasture, and one of the mechanisms or the strategies that the horses take is to selectively avoid grazing those areas. Right. So because the closer you get to the defecation areas, those islets you see with the roughs in the pastures, the higher the infectivity is, the higher the concentration of parasite larvae per kilogram of grass or whatever you want to measure it by. And so it's a good idea if you're going to rest that pasture, and we're looking at July, August, it's a very good idea. It's not a good idea if you're supposed to be turning the houses out tomorrow and it's Danish weather. It's a very bad idea, because you're probably going to expose those horses to much higher infectivity pressure. So it's one of those questions, Peter, where, I'd like to be able to just come up with a simple answer, and then it all of a sudden gets so convoluted and complicated. But it has a lot to do with the weather. And one of the things we did in the computer simulations that I mentioned before is we've set them up to actually be able to import weather station data from any weather station in the world, and it can take that climate into account and predict what pasture infectivity will be, depending on what age group of horses, et cetera, you have on the pasture and the stocking density and all these other things. But the seasonality of when parasite transmission occurs is different between different parts of the world, different states in this country. And one of the reasons why we can't really just issue a one-size-fits-all set of recommendations, it depends on when things pick up and when they slow down again. And in some areas, you'll have a short and pretty intense season. And here in Kentucky, we probably have a 75% of the year parasite transmission season. It starts probably in March, April, and it extends all the way into November when things start getting a little too Danish.
Yeah. Yeah, it's one of the things I hear all the time is, want a good hard frost to kill all the parasites and everything. And I'm just sort of thinking, nope. They're sitting back there enjoying this.
Yeah.
Yeah, and that's really good you brought that out.
Yeah, and I mean, there's a lot of challenging sort of mindsets and conceptions in my line of work. I think I spend at least as much time just trying to explain these things and thinking about maybe better ways to explain them than I have, and really just repeating the same explanations multiple times. There's a lot of education in this, and I believe as veterinarians in the field, that's what you're tasked with every day, not just with parasites, but with everything, right? So,
okay. What does the future hold for Martin Nielsen?
Oh, yeah. Well, I never imagined I would be here 10 years later, but, I don't know what I was imagining. I think we, as a family, said to ourselves and each other that, okay, let's give it a couple of years and see where it takes us, and time just flies. And it's kind of unbelievable. It's already been 10 years. And so, I don't see any reason, I don't have any reason to leave right now. I think, like I said, I can't really think of any better place to work, any place where I would fit better. I feel like that sense of a purpose is something that, gives you great satisfaction in your work. You guys can probably relate. And it's certainly something I have working here. So, the Gluck Equine Research Center, we're undergoing a lot of change right now. It's actually, to some degree, I'd say scary, but certainly a huge responsibility for those of us that are still here. We are in the middle of a major change of generation. Lots and lots of big name faculty scientists that are retiring. We have 4 retiring just in a couple of months. We have a big reception, I think, in a couple of weeks out of Keeneland, and it's for the really, really big name people that have served this industry so well for so many years. David Horohoff, our current chair of the department, is retiring, and Peter Timoney, rock star of infectious disease, and who's like we'll never see again, to be honest. He's retiring. We have Barry Ball, our professor of equine reproduction, a huge player in that field. And before he came here, he was at UC Davis. I mean, he's been such a fantastic contributor to that area. And then we have our director of the VDL, Veterinary Diagnostic Lab, Craig Carter. They're all retiring and stepping down on the same day. And so that's just right now. But we've seen lots of people retiring in the years leading up to now, and we actually have quite a few more on the immediate horizon. So kind of bringing Gluck into the next era is kind of what we're faced with. Like I said, it's scary. It's a big responsibility. It's also a huge opportunity. Right? We have a chance now to rethink who we are, where we want to go, who we want to be, and shape this institute for the future. And I do feel strongly about this place, as I hope I've made clear. We're in a transition right now. We're kind of looking to see who's going to be our next chair and director of the Gluck Center. And the dean decided to invite applications for an interim position, so a 1-year deal, so we could get someone in the office while we are getting the real search together. And my colleague Dan Howe has been appointed, and I was appointed as the associate chair. So I'm, at least in an interim term, I'm part of the leadership. We'll see what the future brings, but I'm very excited about that. I think one of the things that we really need to make sure that in throughout this process that we do engage our stakeholders a lot in this. They have a big say. They're the whole reason why we're here, and talking to you guys, talking to all the clients, the horse owners, and the managers in this area, I think is incredibly important as we move through this. So I'll be engaged with all of that, and it is exciting, but like I said, also a huge responsibility, sort of shaping the next stage of, or the era for Gluck.
Yeah, and it's good though to have you talk here about what you do and give people an insight to just what goes on there, because you're exactly right. There is just nowhere else like this in the world, with the concentration of people and horses and the sort of the financial resources to actually make things happen.
Yeah.
You know, we take it a little bit for granted what all goes on at Gluck, but we're all the beneficiaries of what happens there. So
Yeah.
anyway, like you said, it's an opportunity.
Yeah, but I also want to emphasize it goes both ways. For us, that feedback, that interaction with people in the industry, asking us questions, informing us about things that are going on, I think is equally important. It kind of keeps us on the right track. It ensures that we're doing things that are useful and beneficial to the outside world, and keeps us out of the ivory tower. And so those are all important things. And so, we'll see. I mean, it is very exciting, and I certainly still have a lot of research projects going on. We don't have time to talk about all of them, but I spend quite a bit of time talking about several of them, and my team and my grad students, and which is something I enjoy a lot.
Well, Martin, thanks for being with us. It's I think when it comes to parasites, people want a formula. They just go, just tell me what to do, and so we don't have that. What resources do people have if they want to learn more? Where can they go? And specifically mention your YouTube channel, if you wouldn't mind.
Oh, absolutely. Thank you for bringing that up. You know, I spent some time trying to communicate through various different channels, and I think as a scientist, as a researcher, we do all have an obligation to try and communicate to the end user. I mean, we can get our scientific papers out. We can go to the scientific conference and give a 12-minute talk and 3 minutes for questions. That's all important too. But we do need to ensure that we deliver information right sort of at the eye level of whoever is the recipient. And so I've been experimenting with that. And I have my own YouTube channel. It's called Martin K. Nielsen Equine Parasitology. And I try to, some would say silly videos, but you know, I want to try to make them edutaining, if you will. So if there's a little bit of goofiness and silliness, it goes a long way if it keeps people entertained and actually and keeps their attention. So I've kind of done a few different video series. I did quite a few last year when we all were like, okay, COVID is here, we have time. That was last year. Now this year has been, okay, COVID is here, we have no time. I don't know what happened there, but so I haven't had time to do any videos this year. Actually, I'm actually about to make one, so there's going to be a few more posted. So I have that. I do try to post about things that are happening at Gluck at our Facebook page. So we have the MH Gluck Center Facebook page, so you can look that up if you search on Facebook. And we try to sort of talk a little bit about some of the work that we do. The people who are comfortable with appearing on social media, it's not for everyone, but certainly some of the younger people, younger than me, that are willing to do so, I try to help them get something posted and sort of post some of my own stuff as well. And then one document that is actually useful for the interested reader to read is that guideline document I mentioned before, the AAEP Equine Parasite Control Guidelines, that are available for free, and a lot of people read those and make sense of it. We've also published a book. I have the Handbook of Equine Parasite Control, second edition. I mean, so we're trying to, whatever the channel is, trying to help out. There's several Facebook groups that are sort of Ask the Vet type Facebook groups, and I am on several of those and try to, if I have time, to kind of look, has anyone asked anything about parasites? And if they have, I try to chime in and sort of, you know, provide my 2 cents worth, and sometimes maybe a little bit more of an up-to-date answer that some of the vets that are on those groups might also benefit from. So there's also vet-to-vet Facebook groups that I try to also be active in. So I really try and make use of the social media as well as all of the traditional channels. So we'll see if it does anything. At least I had fun while I was doing it. And the other thing I wanted to say, what it does for me, is a little bit of the same that I talked about before. I get an idea of what types of questions people have and what misconceptions might be out there and what concerns that are out there currently, and those may change with time. And that is incredibly important for someone like me to really have a feel for what's going on in the real world. So for me, it does that, if nothing else.
Mm. No, that's good because, as Bart alluded to, people just want a recipe. They want to do something on the calendar, and it's a whole lot more complicated than that because, let's face it, we're in the position we are in with equine parasites.
Yeah.
Because that was the mindset.
I often just post a link to one of my videos.
Yeah.
I go, watch this video and let me know if you have any questions. So,
well, we're glad that's out there because I'm sure it's really helping people.
Yep. Appreciate you being here with us today.
Yeah, it's been really good, Martin.
Thanks for having me.
No, it's been a pleasure. And that was Stallside. We were talking to Dr. Martin Nielsen from the Lux Center on Parasitology. See you next time.
Why the podcast? Root and Riddle Veterinary Pharmacy has a relatively small marketing budget, especially when you compare us with our competitors. I understand that marketing is important, but telling people that you exist and what you do and why your products or services are different is a must. I thought about what makes us unique, and I realized I wanted to give people something of real value. That's how the podcast idea evolved. I wanted to use the money we had set aside for marketing, not to tell people who we are, but rather to show them, to open up how we do things and give something of value at the same time. The content of this podcast is designed to do exactly that. It's not going to serve as a shameless plug for pharmacy products or services. We want you to know who we are, that quality is uncompromised, that we care about people and their animals. If there are specific topics that you would like us to cover or guests that you would like to hear from, please email us at stallside@rrvp.com. Hope you enjoy the show. Just one more note. Nothing that we talk about here today should be construed as veterinary advice. That's why you have a relationship with your own veterinarian. Thank you for listening.